Hey deep divers, ready for a deep dive into the world of carbon?
Always up for a deep dive.
We're going from basic building blocks to, like, the bling on your finger, all thanks to carbon.
Oh yeah, carbon's more exciting than most people realize.
We've got some excerpts here from Wikipedia and a Chemistry LibreTexts article to help us break it all down.
Sounds like a plan.
So what makes carbon so special?
Well, it's everywhere, right? It's the backbone of, well, basically life as we know it.
Right, but it's also in diamonds.
Exactly. And get this.
Yeah.
It can be tougher than diamond or softer than the graphite in your pencil. Wild, right?
Okay, so before we go full-on science fiction,
Right.
let's talk about what makes carbon unique at, like, the atom level.
So carbon atomic number 6, right? The cool thing is it has 4 valence electrons.
Okay,
Goes-
4 valence electrons.
Now, think of those electrons like little hands reaching out wanting to connect with other atoms. That's how molecules are built.
Like little chemical handshakes.
Exactly. And because carbon has 4, it can hold on to more atoms than most other elements, and those bonds can be single, double, even triple bonds.
Wow, busy little atoms.
It's like the ultimate Lego set for chemistry. You can build almost anything.
So that's how it ends up in, well, everything. From the air we breathe to.
To those diamonds.
So there's, what, like different types of carbon?
Well, you have to differentiate. There's organic carbon, the kind found in living things or things that were once alive, like plants, animals, fossil fuels.
Right.
And then there's inorganic carbon found in rocks, minerals,
Yeah.
released by volcanoes.
Volcanoes.
Yeah. Think of the CO2 from an eruption. It's still carbon dioxide, but it's from a very different source than what we get from, say, burning coal.
So even though we need carbon for, like, literally everything,
It's the basis of life.
too much of it in the wrong place is where we get into trouble.
Exactly. Like with all the talk about CO2 and climate change.
Okay, so we've got different types of carbon, but then there's these things called allotropes. Everyone knows diamonds,
Of course.
but fullerenes, those sound like something straight out of a sci-fi movie.
They do, don't they?
They sound kind of cool though, right? Like fullerenes.
Yeah, they're pretty remarkable. So picture this. Back in 1985,
Okay.
scientists, they blasted graphite with lasers.
With lasers.
Yeah, and discovered these like cage-like structures entirely made of carbon atoms.
Okay, blasting stuff with lasers.
Yeah.
That's definitely sci-fi movie territory.
Right.
So what do these fullerenes, like, actually look like?
Well, the most famous one, Buckminster fullerene, it looks exactly like a tiny soccer ball.
No way.
Yeah, or a geodesic dome, if you've ever seen one of those.
So we're talking, like, perfectly symmetrical, hollow cages of carbon. That's wild.
What else can carbon do? I mean, besides
Oh, you were talking about diamonds before, right?
Right.
Made of carbon, too.
Yeah.
Let's get into that a little bit. Like, why a diamond is so different from, say, graphite,
Yeah.
even though they're both pure carbon.
One's for, like, writing, the other's, symbol of love and commitment.
Exactly. And it all comes down to how the atoms are arranged, how they're connected to each other. So graphite, it's like a stack of papers, Okay.
Layers of these carbon atoms, all arranged in a flat hexagonal pattern. They can slide over each other really easily.
Okay.
And that's why it feels slippery.
Makes sense.
We even use it as a lubricant sometimes. Plus, the electrons, they flow easily between those layers, making it a good conductor of electricity.
Oh, okay. So diamonds, though, on the other hand, they're totally different. Diamonds, they're rock solid.
Exactly. And that hardness comes from how the carbon atoms are arranged. It's not flat layers like graphite.
Okay, so how are they arranged?
Think of each carbon atom holding hands with 4 others,
Okay.
but in a super strong pyramid shape, not flat.
Oh, okay. So it's like a
Like a tiny super strong jungle gym.
right. And that makes them, well, crazy strong.
It's one of the hardest naturally occurring materials, for sure.
But then we can also make them in a lab now, right?
And? Yeah.
Are those lab-grown diamonds, or are they as good as the ones that, come from the earth?
That's a good question.
They're still pretty expensive.
They are. And look, they might not have the, romantic history, of a naturally formed diamond.
Yeah.
But here's the thing. We can fine-tune the properties in the lab so we can make them tougher.
In some ways, yes. Especially for industrial uses, like you need a super strong cutting tool. Lab-grown diamond. High-pressure scientific experiments. Lab-grown diamond.
Wow. I think I even heard about like diamond-based microchips. Is that real?
It's a huge area of research, and then there's carbon fiber.
Oh yeah, carbon fiber.
Another example of how we can arrange those basic carbon building blocks, but this time into these thin, crazy strong fibers.
So it's really strong, but also lightweight.
Exactly. Lighter than aluminum, but often stronger than steel.
No way. How's that even possible?
Carbon. It's all about how we structure it, and
Yeah.
you're seeing it more and more.
Yeah, airplanes, expensive cars, even my bike helmet.
There you go.
But what's the real advantage? Besides just sounding cool, which it does.
Well, lighter materials mean less fuel, right?
Mhm.
So better fuel efficiency in cars and planes. You can go farther on less fuel. And that has huge implications for, well, for the future of travel, space exploration,
Yeah, yeah.
and in sports. A lighter tennis racket, a faster bike, every little bit helps.
That's so cool. Wow, we've covered a lot of ground here, from like the carbon cycle to diamonds to carbon fiber. It's amazing how much one element impacts like everything.
It really is. Carbon's the best. It's pretty great. So where does this all go? What's the big takeaway for our deep divers?
Well, I think it really highlights how incredible this one element is.
Yeah.
And it makes you think about all the possibilities and the challenges too, because as we learn more about how to like manipulate carbon, create new forms, we have to be mindful of the impact.
The ethical implication
Exactly.
of like diamond mining, new materials.
And of course, the environmental impact of, carbon emissions, it's all connected.
It's all connected.
Up.
Well, this deep dive has been amazing. Learned about the fundamental building blocks of carbon, its crazy versatility.
It's a wild ride, this carbon.
And we even touched on the future a bit.
The future is carbon-based, I'm telling you.
Maybe. To all you deep divers out there, thanks for joining us on this incredible journey through the world of carbon. We went from basic chemistry to, like, cutting-edge tech. And until next time, keep those brains buzzing. We'll catch you on the next deep dive.